We're going to look at question 3 from page 14 on the chi-squared test for independence. We can see from this question that we have 4 groups, that's the USA, the UK, Japan and other. So we have 4 countries of origin and we had 5 opinions: very good, good, okay, poor and very poor. And what we want to test, and what we're being asked to test, is whether somebody's country of origin has an association on their opinion of the hotel. So the very first thing we do is we state our hypotheses. So H0, always the null hypothesis. There is no association or there is no relationship between the guest's opinion and the country of origin of that guest. H1 is always the opposite. There is an association or there is a relationship between the guest's opinion and the country of origin of that guest. We are also told in the question to test at the 5% level of significance. So once we've stated our hypotheses, we've got to lay out our tables. We have our columns across the top, our opinions: very good, good, okay, poor and very poor. And you have got 4 blocks of calculations to do: the USA, the UK, Japan and other. So once you've laid those out and you've filled in your observed values that you're given in the table, you need to add up your row and column totals. So the observed values for the USA, if you add 10, 24, 20, 32 and 25, you get the total 111. You add up the observed values for the UK and you get 76. For Japan is 40 and for other is 75. You need now to do your column totals. So your column totals for very good are 49, for good are 66, okay is 76, poor is 66 and very poor is 45. You now must double check that you've got your row and column totals correct. If you add across your column totals, you will get the grand total of 302. And if you add down your row totals, 111, 76, 40 and 75, that also comes to 302. Now you start working on the individual calculations. As you can see, I've only got the USA blank. I've already calculated the UK, Japan and other. Because it's very repetitive what you do for the USA, you do exactly the same calculations for the others. So the first one we calculate is the expected value. If you can remember, that's the row total times the column total divided by the grand total. So in this first case, the row total is 111 multiplied by column total is 49 and the grand total is 302. For the next one, the row total is still 111 because we're still in the USA, multiplied by column total for good, we can see is 66, divided by 302. And the next one, row total 111 multiplied by column total is now 76, divided by the grand total. As you can see, the larger your table is, the more repetitive this gets. 111 row total, our poor column total is 66, divided by 302. And for very poor, 111 times 45 is our column total, divided by 302. What we ought to do at this stage is do a double check that all our expected values still add up to our row total of 111. We haven't lost any USA citizens, we haven't gained any. All we've done is reapportioned their opinions. Let's just get rid of that total. We don't need it there. That was just a double check to make sure we hadn't made any mistakes in calculating our E value. We then do exactly the same for the UK, except our row total is now 76. And then we do the same for Japan using the row total of 40, and the same for other using the row total of 75. Also, as a double check, if we add up all our good expected values, we will come to 49. We haven't made up any more good opinions or lost any good opinions. Again, we've just reapportioned them over the country of origin. So that's a double check to make sure we've got all our E values correct. Moving on to the next row, we now have O minus E. Well, very simply, first case, that is 10 minus 18.01. And then it is 24 minus 24.26. And then it is 20 minus 27.93. And then 32 minus 24.26. And then 25 minus 16.54. The next row is O minus E squared. We've got O minus E, we've just calculated it. When you square something, you multiply it by itself. So, for very good, it's minus 8.01 times minus 8.01. Oops, I'll type that in wrong. You'll notice that when you multiply two minus numbers together, the result is always a plus number. So minus 0.26 times minus 0.26 equals minus 7.93 times minus 7.93 equals 7.74 and 8.46 times 8.46. You just have to be careful that you're hitting the right numbers on your calculator, particularly when you're doing this a number of times. We're doing it for each country. It does get repetitive and you can be prone to just typing the wrong value in, so just be careful. So the final column, O minus E squared divided by E. Well, we've got O minus E squared, we've just done that. We've got E, we did that a little while ago. So, first one is 64.16 divided by 18.01. 0.07 divided by 24.26. 62.88 divided by 27.93. 59.91 divided by 24.26. And 71.57 divided by 16.54. You'll see that this one here has come out as 0. That's just because it probably has got a few number of decimal places. I've just chosen to display it to 2 decimal places. So it's probably 0.00025 or something like that. That's okay being 0. Once you've done your first country, then do exactly the same for the UK. You calculate those 3 rows of data, then the same for Japan, and then the same for other. During our lectures, I've told you to, or suggested, that you highlight this final chi-squared value that we've just calculated. You highlight it or you circle it. Because the next thing that we do is we've got to pick out each of those values and add them all together. And as you can see from this example, when we've got a bigger table with more numbers and more categories and more groups, your work can get more confusing. If you haven't laid it out very, very neatly, it can be quite easy to pick up the wrong value. So when we add all those values together, we get what we call our chi-squared calc value, and they all add up to 32.86. We call it chi-squared calc because that's the value that we've actually calculated. What we need to do is we need to know whether that chi-squared calc value is large enough to enable us to reject H0. And the two things that we need to enable us to do that are the degrees of freedom and the level of significance. We're told the level of significance to use in the question, and that's 5%. The degrees of freedom for the chi-square test of independence is the number of rows minus 1 multiplied by the number of columns minus 1. So in our example, we have got 4 rows. They are the observed values for the USA, the UK, Japan and other. And we've got 5 columns, the observed values for very good, good, okay, poor and very poor. So rows minus 1 is 3, columns minus 1 is 4, 3 times 4 is 12. So on our chi-squared test for independence tables, we look down the 5% level of significance column and across the 12 degrees of freedom row, and we will get a value of 21. And we call that chi-squared tab. Tab meaning we've read that value from the table. We now need to make a decision. We compare our chi-squared calc value with our chi-squared tab value. And in this case, our chi-squared calc value is higher than chi-squared tab, so the decision we make is to reject H0 at the 5% level of significance. Let me put that into words. What does that actually mean? Well, H0 was saying there is no association between the guest's opinion and the country of origin of that guest. We've rejected that. We've said that's wrong. So what we are saying is that there is evidence to suggest that there is an association between a guest's country of origin and their opinion of the hotel. If we're saying we have got a relationship or an association, we need to look at our chi-squared values and see if we can find any major contributors. Well, if we look at our values that we have highlighted here, 2 numbers stick out as being larger than the others, and are the 4.33 and 4.24. Look at 4.33 first of all. What is that? Well, that is people from the USA or Americans. We have got more of them rated the hotel as very poor than we would have expected. And our 4.24 is the UK. We have 25 of them rated the hotel as good, and we would have only expected 16.61. So more people from the UK rated the hotel as good than we would have expected. If those 2 values hadn't been so large, then our chi-squared calc value would have been smaller and we might have made a different decision. On this table there are also 2 other values that are, one other value that is fairly large, and that is the 3.56. We could also comment on that, but for this size table, to be perfectly honest, 2 major contributors are really enough. But you would not lose marks for also saying that the 3.56 was a fairly major contributor. And that is, fewer people from the UK rated the hotel as very good than expected. We only had 10, we expected to have 18. And that is the chi-squared test for independence, question 3 on page 14. Thank you.